Hello, this is Embedded. I'm Alicia White alongside Christopher White. We are joined this week by Maria Gorlatova from Princeton University.
Hi, Maria. Thanks for joining us today.
Hi, Alicia. Hi, Chris.
Could you tell us a little bit about yourself?
Sure thing. So I am currently a research scholar at Princeton, where I work on an exciting area that's currently known as fog computing or edge computing, bringing computing closer to the endpoint devices. My background is in the Internet of Things in general. My PhD is from Columbia in developing ultra-low power energy harvesting tags for the Internet of Things. And I have several years of industry as well as academic experiences spanning actually a wide range of developments from research to business strategy.
Excellent. Oh, wow, plenty to talk about. Before we get more into that, I want to do lightning round where we ask you short questions and we want short answers.
Of course.
And if we are behaving ourselves, we won't ask you why and how and all of the other questions.
All right.
What science fiction concept do you think will be real in our lifetimes?
Oh, so many of them. Basically, you take the Black Mirror videos, and half of what you see there will, fortunately or unfortunately, be real. Drones, for example, are up and coming within the next few years. So is this idea of very responsive spaces, and augmented reality. Of course, that's going to be huge over the next 10 years.
What's your best marathon time?
4:04, and I'm working on cutting that down to 3:45.
That sounds probably 12 times faster than I could manage it.
What is your favorite embedded processing platform?
Oh, that is an unfair question. It's something ARM-based, I guess.
It's a safe answer.
That's pretty broad, though.
What's your favorite programming language?
I have to say Python.
If you had to choose one, research or teaching?
Research. I'm a research and working with students, teaching students one-on-ones while conducting research.
Yeah, I can see that. All right, so now for something longer. Can you describe what a typical work day is like for you?
The way that researchers like myself work, we have a combination of things that we do hands-on in one-on-ones and in larger groups. So my typical day has a mix of all of that. There's some element of working by myself as writing papers, for example, or doing experiments or developing something. Then there is a part where I work with students, help students with their next steps and next directions. And then I work on several big projects. So projects that, for example, span multiple universities and some industrial organizations, or Open Fog Consortium that spans many dozens of organizations across the world. So on any given day, there is an element of that as well. A call with a lot of people or some element of planning with a large group. So really a mix of experimental work, development, as well as working with other people.
Sounds very normal.
It is indeed, yes. It's, yeah.
Okay, so what are you working on now? I mean, what is the Open Fog Consortium, and what are you working on now?
So I'm currently working on the space that's called fog computing, or sometimes it's called edge computing. And this is bringing computing capabilities closer to the end users. So taking what was developed for the data center and bringing it closer to the embedded devices. So, for example, bringing computing capabilities towards your local gateways, or bringing a computing box into your house or into your region. So this idea of distributing traditionally centralized capabilities down closer to the end users. This is the idea of fog computing and edge computing, and it's really transformative in a way for IoT nodes, as it promises to bring additional intelligence and additional reactivity to the IoT. Within this space, I personally work on several different aspects of it, on characterizing it, on figuring out how to use it for example, for distributed machine learning or for making IoT devices more responsive. On the consortium side, we are working on standardizing related fog computing architectures. Open Fog Consortium is a very large nonprofit comprising about 50 organizations in industry as well as in academia. We've released a reference architecture for fog computing platforms, and we're currently working on developing an IEEE standard that will get the entire industry going towards a standardized fog computing approach.
What is this reference platform for fog computing?
So we've developed a reference architecture that we've published earlier in this year, in February. It is publicly available on the OpenFog website, and it outlines the vision for fog computing from the business side as well as from the technology side. This is it outlines the important, what we call pillars or principles of fog computing, the key aspects of the architecture that all the different players in the space need to follow to develop solutions that are appropriate for fog, distributed, scalable, secure. The reference architecture was released earlier this year, and currently an IEEE standards working group has been formed to develop a standard for fog computing architectures. The reference architecture will be one of the inputs into the standard, but of course, it being an IEEE standard, many companies in the space are welcome to contribute. We plan to release an IEEE standard by April of the next year, basically.
And so this isn't a specific, you should use a Raspberry Pi or a Cortex M4F sort of architecture.
Yes. So this is an IEEE standard that describes the functionality and the requirements rather than specifics of an individual platform.
How can it possibly do that when edge computing is such an enormous, it's a huge field. It covers farming, it covers drones, industrial. These are just hugely different environments and hugely different requirements.
Yeah, so the way that we're taking towards standardization is to identify one global approach and then to identify, create substandards that cover some specific areas of the space. This type of a standardization approach has been tried in medical devices, that there is an overlying, what they informally call an umbrella standard. And then there are a number of smaller standards that concern specific elements of the space. Indeed, the use cases, there are many different use cases for fog, and we've outlined a number in the reference architecture and are currently working on specific use case definitions that address some parts of the space. For example, working with several other people, I recently helped release a use case that outlines fog and autonomous driving, this vision of connected vehicles and connected cities, the vision of how fog enables a fully connected transportation experience, basically.
So you're defining the architecture and laying out some ideas for how it should be implemented at a high level, not at a very tactical implementation level. Is that right?
That is correct. Yes, a lot of the work on currently, given the state of the space, a lot of the work goes in that direction. Yes, my own hands-on work goes, of course, more towards the technical details, towards some specific elements of this.
It's hard because some of these things we are getting now. We're seeing many of the edge computing devices happen, and we're getting distributed sensor networks, but they are disorganized. And
yes.
How are we going? What is the path to go from, okay, ship it now to let's ship something that works together?
Yes, that is a very, very difficult question. I think that's the overall state of the IoT right now, is that we are in a space where we are creating a fragmented field where getting things to work together is extremely difficult and extremely challenging. What makes me personally excited about OpenFog is that it represents many of the leaders of the space. So Intel is there, ARM is there, Microsoft to represent the cloud computing side, Dell, Cisco, Hitachi, many others. What I think is very exciting about the reference architecture is that it represents an agreement amongst these companies as to what the architecture is supposed to look like. You do, of course, always have this pressure to ship immediately, and there are some companies that are very keen on creating their own solutions. So that is definitely one of the challenges in the space.
One of the things we hear a lot about with the edge computing and embedded systems that are connected to the internet is security, and how that is, wow, that's going to bite us, and it's going to bite us often. I mean, it has the potential for some serious disasters. And we've had some botnet attacks from televisions. It's insane. And when our toasters attack, what's going to happen? Is this one of the ways you're convincing people to join and adopt the standards, by helping them sort out these very common problems like security?
Yes, security is a very big part of the work that the consortium is doing. That there are pages and pages of specifications and discussions that span the world, as there are different standards related to security in different parts of the world. What I think is some of the interesting elements of security in edge computing, they're not so much in what we immediately see as to where we can take us in the future. I think what's very exciting, there are two very exciting elements of fog computing that have a promise to make IoT secure as a whole in the longer term. And one of them is local processing of data. That if you, with edge computing and with approaches like federated learning, for example, you no longer have to transmit all of your data to the cloud. You can keep your own local data locally, while still performing complex cloud operations. This means that this has the potential to fundamentally improve our privacy, that we no longer will have situations where, for example, videos that are captured locally are available for everybody on the cloud once something is hacked. The other, and this is a little bit further down the road, there are some deployments like this right now, but this is more of a research, a 3 to 5 year plan, more than right now. The other very interesting element of edge computing is that you can run complex intrusion detection algorithms locally on edge nodes. We currently have some of this work going in our lab, and I think a number of other people will as well. Ultimately, you are currently, without things like fog and edge, you are connecting immediately and secure devices right to the cloud. With edge, what you can do is you can put this smart middle box that will be able to contain an attack, for example, or detect locally malicious behavior. I'm very excited about this. I think that this will bring IoT security closer to the level of enterprise security within the next 5 to 7 years.
What is this smart middle box?
What you can do with fog computing is that you can put on your local edge node, for example, you can put their security modules that would be, for example, looking at what's typical of the local traffic and filtering out what's not typical, or performing some local anomaly detection. So the smart middle box is a functionality within the edge node or a fog node.
So is that a functionality that would go into my router, or would it be
your local gateway, your local computing device? Yes, pretty much.
Or some sort of home IoT hub.
Right, that's exactly right. Yeah.
That was my other question. Is it the Philips Hue hub that goes and
For
talks
example,
and converts between internet and whatever the Hues speak?
Yeah, for example, yeah. So you can, that box, theoretically speaking, working with the cloud together, this box will in the future be able to run complex security-related algorithms. And I think this is one of the very promising angles to keeping the IoT secure in the longer term.
So I have a kind of a higher level question. Is the drive for this, is it a purely technical capability drive? Like, oh, now the embedded processors are so much more powerful than they were 5-10 years ago that we can push more functionality down to the edge? Or is it a necessity thing? Like, well, the security model we have right now for IoT just doesn't work, and moving more stuff. So is it just a happy coincidence that both things are converging, or was there a drive before to say, well, we don't quite have enough computing power, but what can we do to start addressing this problem?
I think there are several converging trends in this space. One. But the embedded device is becoming better, but the drones and augmented reality and virtual reality, these types of high-end applications, you really need you need computing available at the low latency. So one of these drives is this kind of existential scenario that things like augmented reality, for example, they just cannot move much farther than they are right now unless there is a local computing capability. The response time from the cloud is just too high. So that's one of the patterns. Another one is that as the IoT starts scaling, we just cannot keep sending everything down to the centralized network. It becomes too expensive, and it becomes very costly for network designers as well. So the more for companies like Comcast, for example, the less their network is loaded, the more control they have over their network, the better is for them. So part of the drive is coming from that space as well, being able to keep up with this coming flood of information and with the coming avalanche of IoT devices. Some of them produce very high volume, high velocity data, while still keeping the network side of the things manageable.
So part of this is a networking problem.
Some of it definitely, yeah.
Trying to put nodes on the network that can serve data instead of having a single computer being the final source for the data.
Right. Yeah. So the data and content as well. So, for example, for things like virtual reality, for example, it's not that let's say that there are a few of us in one place who want to enjoy a similar experience. It doesn't make sense for all of us to keep reaching for the information far away. It makes more sense for some of the content and some of the processing to be done closer to where we are.
It's weird to think that there's processing being done not where we are. I mean, this goes...
Yeah, I know. Yeah.
The cloud, I mean, part of me is like, okay, this fog thing is odd, but really, it's the cloud part that's completely bizarre.
Yes.
I mean, the cloud is just somebody else's computer.
Yeah, this is the reversion to normal.
Yeah, so we somehow got used to this idea that for us to do something locally, the signal has to travel to Seattle. And that is somehow okay for us. But I think what we were able to do with the cloud is solve a lot of actually very important challenges of computing, how we distribute workloads, how we ensure availability, how we ensure safety. And so one of the challenges of fog is to be able to capitalize on all of those developments while keeping the computing distributed.
It's funny. This kind of reminds me of a swing back and forth that happened and continues to happen, I think. But when I was first working, the workstation I got was an X terminal, and it went back to some larger computer server.
Big computer.
Yeah.
And in fact, I had one at home, and it would go over ISDN, and I would do most of my work on that. And then they replaced those with workstations that had enough computing power. And then a few years later, the whole Citrix thing happened. So we've been going back and forth on this, and now it's happening to consumer devices. I have no point. It's just funny.
Yeah, so there's a pendulum that they call it in the distributed systems community.
Yeah.
And you talked about the avalanche of data and IoT devices. And part of me living in the bubble that Christopher makes for me that has all of our devices connected to all of the other devices, I'm like, how can we get more connected? What is this avalanche of data? What are we going to be seeing?
Basically, currently the amount of video that is being produced is at the level that can really start to overwhelm networks. Once you install enough 4K video cameras in different places, you will not be able to transmit this raw feed to the backend. That becomes prohibitive. A related area is things like smart cars or drones. They produce enormous amounts of information, a lot of it having to do with video or other sensor data that is dynamic, that is changing fast. Video is and the video can keep getting better and better as well. So that's there's a bit of a race there, I think, in terms of how much sensing data you can generate and how your network can support it.
I've been taking a little bit of machine learning, and so I've been looking more at videos and how intelligent devices can be with object identification and image segmentation. So you're saying that instead of sending back a 600 by 40 pixel 24-bit color image, we're just going to send back and say, oh, there was a dog.
Yes, and in addition to that, you can create very interesting scenarios where what you immediately send is to the cloud is that there is a dog. But if you want to investigate this further, then you can query local devices for additional information. There's somebody in my lab is working on a very similar idea for cars, that a car camera sees an object that if the object is not of immediate interest, you just say that you saw this object and that gets stored. On the other hand, if an investigation is required, if the object starts becoming interesting, then additional processing is performed in a mix of local and cloud conditions.
Why do we need cloud conditions for driving? That seems like a single system thing. For things like, for example, querying this centralized data that is collected, not for the immediate actions of driving, not for the control of the car, but more for example, processing the information that is collected from a number of cars. So is this like when there's a large debris in the road and after 5 cars have seen it? Then,
for example, yeah.
Then then it can be dispatched to be cleaned up.
For example, yeah.
Or for training, right? If you're getting a lot of data from a lot of cars, you can improve your algorithms, but you don't want to do that on the cars.
Yeah, that is one possibility. Or there is a use case that is talked about quite a bit. This is this element of detecting Boston bombers, that you had to have the feed from many different people's cell phones and many different cameras to get the whole idea of the situation.
That's not terrifying.
Do you think we will have self-driving cars, fully self-driving cars soon? And I am going to let you define what soon is. So,
I have a bit of a personal angle on this. Is that self-driving cars tend to come from places where the weather is very good, and I'm from Canada, so I cannot see in anything that is happening right now how a car could navigate a winter storm in Ottawa, for example. I think that I like the story of autonomous cars and autonomous driving scenarios first appearing in things like, for example, trucks in truck convoys in specific places. The fully replacing a human driver on a global scale, that's probably some number of years away. On the other hand, a lot of current developments in making cars smarter are, of course, very exciting. So while I don't necessarily see us replacing human drivers entirely in the next 10 years, say, I think there's a lot of cars and smart cities working with cars can do to really improve everybody's experience and safety and the flow of traffic in the city. So I'm very excited about the space, but I do not quite see us getting to the fully autonomous level 5 autonomy state within the next decade.
Certainly not in every situation. Yeah,
definitely, yes. Yes, but I was when autonomous cars were first talked about, based on a Canadian experience, I was entirely skeptical because I just could not see it happening.
It is quite a bit easier in California.
Yeah, we might have weather control before.
How does the cloud play a part in that? Are we going to get convoys before we get level 5?
Well, so in terms of convoys, I think that we will get convoys first, yes, because there is a very good use case for them, and because of you get a lot of the things that are already figured out for them. The role of the cloud is more on learning coordination on the longer scale, as well as this idea of kind of offline intelligence. So cloud is a big part of the story, but not for an individual autonomy, I think.
That makes sense. And you mentioned offline learning. Is this where something has gone horribly wrong and it takes the data and then tries to use that data to improve everybody else's experience? Is that what you mean by that?
For example, yeah. Or you can use cloud for things like simulations, for example, that you can run simulations, what if scenarios, just a lot of training that you would not be able to do in local conditions. Some of this is it's kind of what is already done though with mobile phones, that a lot of learning happens in the cloud.
Yes, that makes a lot of sense. I mean, I take a picture and it makes more sense if that goes to the cloud for identification than it's on my phone for identification. But then when I start worrying about privacy and things, it goes back to my phone, because now the big cloud has trained its parameters well enough that it can send them down to my phone and the inference can be done.
That's exactly right, yeah.
I should actually define some of those terms. Inference is when you run the machine learning algorithm feed forward. You're not training it, you're just using it. It's one of those words that I really like, but I always forget to define, and then 10 minutes into a conversation, somebody says, what? And so there we go. That's inference. But on the big cloud, you need the big cloud to train your data because it's an incredibly computationally intensive thing. And so you can't do that on your phone as easily.
There is some research these days and some developments into distributing learning as well, with distributing the element of actually generating the models. And this has to do with privacy, that you may not necessarily want to transmit your raw data to the cloud. So there's a very interesting line of work in using your local devices to do parts of your local training, while using the cloud as a purveyor of global data sets, as well as a coordinator for these local operations.
So this is like when Facebook said, if you feel you're a victim of revenge porn, send us your pictures of you unclothed. And so instead of that, maybe we can just send them the training weights.
Maybe, yes. That would be a very good scenario. Yes, indeed.
How do you distribute machine learning like that? It's a totally new concept to me.
There is a line of work in this space that is called federated learning. It's coming out of Google. That you have to manipulate the details of your learning algorithms. There are specific ways that you can use your local partially trained models and combine them globally on the cloud. It goes into the depths of the mechanisms of stochastic gradient descent.
Okay, and that's how you do the back propagation usually. There are other methods, but that's the most popular.
Yeah, that's right.
And how is your work focusing on this whole stack of cloud to device different than maybe focusing on just the cloud or just the device?
So what's happening right now in the more academic part of the space is that so far the embedded people and the cloud people really do not talk to each other.
Yeah, it's worse than hardware and software engineers.
Even within a single company, that's true.
That's true, yes, very much.
So you have this issue of there's no common language, there are no common abstractions, there are no common even understandings of what it is that different devices are supposed to be doing. Where, if you try to actually fundamentally address the question where I should be placing a particular type of functionality, that is currently pretty much impossible to answer. You have to do experiments, you have to do engineering design towards it. One of the longer terms, how this space can really improve how we can all start moving forward towards more integrated solutions, is to start thinking, starting from device and to the cloud together. So from the ideally, we do not want to, for every single functionality that we develop, we should not have to experiment with its placement. We should just be able to specify a set of parameters that are important for us and get that placement computed for us automatically. Going towards that vision, though, this really requires looking across both devices and the cloud, and this is something that is very new, and so something that needs to happen, but is extremely challenging because of this heterogeneity and mismatch between IoT and the cloud.
It's difficult because on one hand, we want our edge devices to be usually embedded, which to me means resource constrained. Sometimes they need to be cheap. Sometimes they need to be power efficient.
Yes.
Sometimes they need to be physically small. And so you use those constraints and then you do the best you can with putting as many features out there as makes sense, given the constraints, and everything else goes back to the cloud as long as you have a good connection or some sort of connection that can get back. Is that the sort of thing you mean? I mean, for me, it's very tactical. I'm very much an industry person who spends my time trying to figure out how to make those resources be as constrained as possible and as power efficient and cheap and small as possible. Is that what you're looking at, or is it different?
Yeah, pretty much. So the question of what goes into your endpoint device, what goes in your edge node, and what goes in the cloud, that is actually a very interesting question to answer, as you can make many different engineering trade-offs along the way. If your local device is fairly capable and it is within the reach, your local device meaning your edge node, for example, if it is within the reach of your embedded device, then a lot of the functionality of the embedded device can go to the edge node, or it can also go to the cloud, local or remote. And where it fits best is an interesting question, which has different trade-offs associated with it. Power consumption, size of your endpoint device, security comes into play as well. Costs, whether you want to transmit things to the cloud at a cost, or you want to solve them locally, which could be cheaper.
And so you have 3 layers in your model. You have the widget, the device, and then you have the edge device. And so if for example we use Fitbit, the tracker is the device, and then your phone is usually the edge node, and then that goes back to the cloud. And if I use the Hue lights, the lights are the devices, and the module is the edge node, and then the cloud is the cloud. I guess it uses 802.11 to go to the cloud. Is that the right architecture? Sometimes we go direct from device to cloud.
What is currently imagined in a lot of fog computing work is inserting additional layers as well. So having your endpoint device as this is your device, there's your local edge node, but then there could also be other nodes that are between the local edge node and the global cloud. So, for example, your local CDN can serve as one of these intermediate layers. In a smart city, for example, you can have computing boxes that are in your home and on a street corner and in your zip code, such as, for example, the point of presence for somebody like AT&T. So while we are starting with this with a 3-tier architecture, the movement, I think, is going more towards multi-tiers in the future. There's currently work, for example, out of Amazon. Amazon released a functionality that allows you to execute some computing on CDNs, which traditionally only served content. They only served images, for example. But now they've also added the ability to perform some computing there. And I think this is the trend that we will continue seeing, this ability of not just being able to place things on locally or on the cloud, but having multiple options around you, basically, in different physical and logical distances from the end device, as well as with different trade-offs such as power and costs.
And so when you talk about fog, you were talking about this whole thing from cloud to however many layers it takes down to the endpoint. Is that right? Or are you focused in...
I think currently the terminology is... it's an emerging field, so things are changing. Terminology currently is starting to standardize on calling this 3-tier architecture edge computing and calling the more multi-tier architecture fog computing.
Okay. And then that was actually where I was headed, was what are the terms? And then there's the Internet of Things. Mm-hmm. Which is a phrase I hate so much. And I wasn't the person who came up with security is the S in IoT, because I have said that, but I shouldn't take credit for it. I don't know where I got it. Yeah, there is no S in IoT, which anyway, does that have a more formal definition, or is that just where all of the vendors have chucked their fog and edge and embedded computing things into one pile?
You mean the Internet of Things, or?
Yeah. Does it have a formal definition?
I don't know. I think it's a global field that is defined fairly loosely.
Okay,
Yeah,
I agree.
Yeah, I don't think there is a. Yeah.
What are the most important technological issues regarding the whole fog computing? Is it technological? Is it technology, or is it people? I guess that's a 2-part question. Maybe a 12-part question.
Yeah, from the technology point of view, ensuring, so there's a lot, of course, ensuring that you, so one of the strong points of cloud is that cloud works. If you can reach the cloud, it will do what it promised. There are mountains of engineering expertise that went into making that happen. There are special provisions for things like redundancy, safety, backups, you name it. It's mountains of research work, mountains of engineering work. All of that work was done under the assumption that you have a data center where you have multiple thousands of redundant machines that are similar to each other. And that data center is under your physical control. To take all that and distribute it to heterogeneous devices, to regionally distributed devices, to devices that are in physical control of different people, that is extremely challenging. There are a lot of elements to that require non-standard solutions. So I think this being able to provide services that are as reliable as the cloud in fog is going to be it's definitely solvable, given that this has been done for the cloud, but it will require a lot of engineering creativity, a lot of engineering work. The other element is just making use of fog. So for things like, for example, AR, or even improving mobile experiences from mobile phones. Let's say that you have this local node. What really is the best way of using it? Is it just to offload your computing, or is there a way of maybe restructuring your computing to make your user experience even better? Things like what I was mentioning before, using edge nodes for security, for anomaly detection, that's taking local traffic patterns and local device patterns into account to make this possible. That's it's very promising, but it will require a lot of work. From the point of learning as well, there's clearly a promise, there's clearly a lot of potential, but to go from this potential to actual solutions that we can all use, that will take a lot of work. From the point of view of people, you've hinted at that before, that one of the challenges is that there are many different players in the space who have different interests. And there is definitely this push of getting something to the market quickly. That is, of course, a challenge that needs to be addressed.
Yes, of course. I mean, and there are so many things that drive that. Some of it is profit, some of it is availability of new technology, the increase of processing power at the embedded systems, at the devices is simply incredible. Mm-hmm. And balancing this idea of, okay, now there's going to be a IEEE standard for this thing that I can just skip around. I can BLE to my phone and have my phone be the edge piece, and poof, I'm done. How do you get people excited about adding layers? How do you convince them this is worth it?
Well, I think It's not that you are adding layers. It's that if you can BLE to your phone, that is an example of a fog deployment as well. So it's not that you are creating layers. It's that you are enabling different elements to work together. The selling point for the kind of standardized approaches here, it's the same as a selling point for the standardized approaches in what was the internet. Is that there is a set of common approaches that allow everybody to build distributed systems on top of it, and you can play in your local settings, but then you are forever restricted to your own approaches. While if different organizations take a somewhat similar approach, then we can create a global substrate, if you will, that application developers can build on.
So it's less about adding layers above my device and more about adding intelligence away from the cloud?
Pretty much, yes. Yes.
That's an easier sell, I think. How do you think all of this will impact consumers in 10 years?
What I think, the IoT systems that we have right now, basically, we talk a lot about smart systems, smart objects. They're not actually smart right now. They're mainly just connected. Your smart object is an object that is connected to the internet. There's no real smartness to it. What is becoming possible right now is to bring actual intelligence, adaptiveness, have actual responsive spaces that truly are smart, personalized, that respond quickly. I think that is a huge transition that we already are on that road with connecting devices around us, but we only scratch the surface. We are only at the very beginning of what can be possible very shortly.
What can you make some examples?
Yeah, definitely. So for example, what currently what your Fitbit does, right? It just counts your steps. Counts your steps, counts your simple.
It does more than that, but yeah, okay, we'll go with that.
Yeah. What your devices can do is actually, so for example, give you feedback on your performance. What is given where you are right now? What should you be doing next? If this is the exercise that you're doing, then will you be more efficient if you change your gait? Will you be doing better if you now find a hill to run up on? Or will you be, given your personal history and your goals, should you be doing something else? This is an example of a smart, adaptive, personalized experience with the device.
It's the personalized that's the exciting part.
Yeah, personalized. There's also this element of having different devices connected with each other. Currently, a lot of experiences with embedded devices actually completely disjoint. Even this thing like AR, for example, I can theoretically play with another person. We can create a common experience, but it's very, very rudimentary. Once we can actually create experiences that are more interactive and common to different people, it's just a very different set of experiences even.
Yes. And okay, so you mentioned augmented reality a couple of times, and I keep wanting to ask more. What technology there? What are you using to get augmented reality, and what do you think you will be using in 5 or 10 years?
So augmented reality currently comes in a couple of flavors. This is phone-based augmented reality and headset-based.
And phone-based is like playing Pokemon,
Pretty much, yes. And the headset based, that's HoloLens, for example. They're both very excited. I'm more excited about the headset based technology, and I'm also very excited about the direction of building augmented realities into cars. So building this experience into a car windshield, for example. But
then we can play driving games.
We could. Where this is becoming very interesting right now is that the headsets are already there, but the help of things like edge computing, you can make them much better. You can make them lighter. You can make the batteries last longer, and you can enable interactive experiences between multiple people. Also secure them. You can really take it from the point of just more or less a very interesting, a very cool prototype like HoloLens into a practically useful, commonplace, scalable technology. I'm very excited about the capabilities of edge computing to do that.
So when I think about augmented reality and cars, I have this idea where the car windshield would highlight things that I might otherwise miss. The bicycle next to me or the pedestrian who wants to cross the street. And they would become red instead of if they were wearing gray or it's night and they're wearing black. And I would be able to see them far more clearly. And possibly on the other side, it might let the pedestrian know that my eyes have looked at that object. I have looked at the object that represents the pedestrian, and it turns something about the car green so the pedestrian knows I know he's there. Is that all plausible? Is that coming? Can I have it tomorrow?
I don't know about tomorrow, but within the next 5 to 10 years, that's definitely where the technology in AR, but also in smart cities, this is where it's heading. The ability of different participants in transport to communicate with each other. That's what you need cloud or fog for. And the ability of not fully automating the driving, but making it safer. That's an excellent use of increased capabilities for in-car nodes, as well as for the elements of cloud to device cooperation. This is extremely exciting and very, very interesting. I haven't thought about the angle of giving the feedback to the cyclists like this before. That could really work.
Having been in San Francisco recently, where I was both a driver and a pedestrian at different times, either one was terrifying. I mean, it's a free-for-all. Christopher, do you have any questions?
Yeah, well, I was to kind of come back to square zero. Mm-hmm. I'd like to get your opinion of where, say you have, you're developing a new product, you're an embedded engineer or somebody who's influencing the overall architecture of the product, and it might have some cloud portion. What would you suggest is the best place to go look at what's the current kind of recommended architecture, whether taking fog into account or conventional standard IoT things? Where should somebody start looking at, okay, I need a new architecture today. What's the best practices?
I don't want to give endorsements here. So
sure.
Basically, currently, there are several cloud providers that are all very interested in that specific business. So all the big four cloud providers are trying to trying to offer options for engineers in this space. Arguably, Amazon currently is farther ahead than others, and this is just my own opinion from what I have seen. It seems to me that they offer some ready-to-go architectures for IoT that are somewhat farther away, farther ahead than IBM or Google or Microsoft. That being said, all of them do go in this direction. So, for example, for offering edge computing functionality, Amazon recently released this what they call Greengrass architecture, AWS Greengrass. Microsoft has a solution that goes in a very similar direction, I am reluctant to give a specific recommendation, but let's just say that when I went looking for a solution, I looked for AWS and Microsoft.
That's interesting. I don't think about either one of those having edge or device. I don't want to say capabilities, but I wonder if that means that one of them will be coming out with, here's a platform, here's an example kit, and here are some sensors and some features and some ways to use our super duper cloud computing out there on the edges.
So currently, AWS Greengrass, that's what AWS released last year. They have partnerships with embedded vendors as well. There is an ecosystem that they are building around it that says which devices can, and there's a set of guides.
Huh. Well, this is something I need to go look at. Neat. Before we close the show, Maria, I have a couple of questions. First of all, how did you get into marathoning?
I needed so I was not sporty as a child. I was not sporty in college. When I got to grad school, I realized that I need a way of seeing progress today from the work that I put in today. As research is it's this very long-term thing where you work very hard for months and you do not necessarily see progress.
Yeah.
So I was looking for something that gave me shorter-term feedback and also that cleared my head. So throughout grad school, I went from a couch potato to an Ironman runner.
That's amazing. How did you convince yourself to do this? I mean, part of it is it has to be a habit. You have to do it every day or at least 3 times a week. But how did you start? How did you get over the hurdle of this hurts and I don't like it?
That's an interesting question. I think I enjoy the experience. I enjoy just being out there. So that makes the pain of how the difficulty of raising your volume worth it. I also had a couple of very good friends who were marathoners and triathletes, so I could see I had good advice. I had good suggestions.
Yeah, this goes back to your parents saying, don't hang out with a bad crowd. The truth is, people you hang out with do matter. And then the other question, you take improv classes. Do you still take improv classes?
Unfortunately, I took them for 2 years while I was in New York City. Currently out in New Jersey, it's a little bit far. It's a long drive. I will take them as soon as I'm in a place where it is feasible with my schedule. I just love it. I think improv is one of the most understated. It's a most understated way of doing many things. It's excellent for developing trust in other people. It's a very specific type of creativity that you create unique experiences based on yours and experience of others. It's unmatched in developing and further exploring this specific type of creativity. And it's tremendously helpful for public speaking as well, that once you are able to make a complete fool out of yourself on an improv stage, there is nothing that anybody at the conference can throw at you and to throw you off your game, basically.
It's kind of like doing balance exercises for your mind, because you get used to getting off balance and then finding a position again that you can talk about. I think improv's magical, and I've always wanted to do more of it.
Oh, do you do it as well?
No, not really. I mean, we started to take a class in college, and the timing didn't work out, but I kind of want to go back someday. It's one of those things. All right, we should let you get on with your weekend. Maria, do you have any thoughts you'd like to leave us with?
Well, so the closing thoughts on my side is that with pervasive systems, with embedded systems, we are at the point where we are it's the tip of the iceberg for what is coming. It's only the beginning of a very exciting, a very evolving part where embedded will truly become a part of our everyday lives, of all of our everyday experiences. And I am extremely excited about the promise of this field. And I'm also very excited at what we can do to start informing other fields as well. Once we do more in digitizing our experiences, we really can start impacting things like, so for example, studies of organizational dynamics or economics. Once we can have data about humans and about humans in everyday environments, we can do better in so many more other fields in life. So I see this as one of the potentially transformative areas of the space, something that we cannot do quite yet right now, given that our pervasive deployments are still fairly limited comparatively. But once we enable the true smart cities and smart environments, this will be a truly transformative for many other areas of our lives as well.
Yeah, cool. Our guest has been Maria Gorlatova, Associate Research Scholar at Princeton University's Electrical Engineering Department. Maria, thank you for being with us.
Oh, thanks for having me.
Thank you also to Christopher for producing and co-hosting. Thank you very, very much to our Patreon subscribers. Thank you for letting me send a microphone to Maria. It just really makes my life easier, so I really appreciate that. And of course, to the rest of you, whether you are subscribers for Patreon or not, thank you for listening. I think our quote this week is going to come from E.L. Doctorow. Is that Cory Doctorow? No, it's some other Doctorow. Okay, from this guy. Writing is like driving at night in the fog. You can only see as far as your headlights, but you can make the whole trip that way. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.